21 through. We're not going to be able to do a big review today because we had to take a quiz, but this is, we're reviewing what we learned yesterday was I can take a complex number and transform it into a polar form. I can write a complex number in polar form, and that's what we learned. We're given a complex number, we want to write it in polar form. When in polar form, you have cosine and sine, and you're going to have a r value, and that's what we did here. All right. So on number 29, we got 1 plus I. To find our r, you got to find r and theta. The r is the same thing as the modulus, the absolute value, the z. You put it on the outside of the parentheses, then we chose this one because it's in the same quadrant as the original problem. And I have that right there. Are there any questions on number 29 or 31? See, one thing you'll be doing this week is pretty much your test will be Friday. There's no way I can feel comfortable getting that test from you tomorrow. So you need to review again tonight. Say, okay, if Mr. Messer asks me to do this, then I know what to do. You need to go through all those different problems we've done and make sure you keep it all straight, okay? It's pretty much what your test is, the notes that are in your notebook, and then this lesson that we did out of the book. All right. And any question on 33 or 35? Are y'all sure? We good on those? Okay. Number 37 and 39 is real simple, aren't they? Because in those you don't have to do a lot of work. 2i. If I was to find the modulus first, which is 2, that's what your r is equal to, that goes out here. And then, okay, if I was to graph the number 2i, what's your real part in 2i? 0. The imaginary is 2, so that means you stay at the pole and you go up 2, the origin. So this is where is this in relationship to a radian? This is pi over what? 2. That's why I chose pi over 2 to be my angle in there. Okay? Number 39, negative 3. If I was to graph that, negative 3 is the real. It will be here and not move. Which radian's over here? Pi. That's why I use pi. Are y'all sure we good on those? How was the quiz?
Easy.
It's okay? Now, your test will not be matching like this. You're going to have to graph them, like the checkpoints. 6 of them. All right, number 41, let's look at this one. We're going to find our r value first, which is our modulus, the absolute value. I square negative 6. That's going to give me 6. Square negative square root of 6. That gives me 6. Square the square root of 2. That gives me 2. 6 plus 2 is 8. 2 square root of 2. Tangent is b divided by a, y divided by x. Square root of 2 divided by negative square root of 6. You multiply by just the radical part. This will stay negative. Square root of 6 over square root of 6, you get negative square root of 12. Break it down. Those cancel out. I'm left with negative square root of 3 over 3. I think, okay, which reference angle has a tangent of negative pi over 3? That's pi over 6. It's negative. It's got to come out of quadrant 2 or 4. Here's 2, here's 4. Look back at the original. If I was to graph this, this will be in quad 2. That's why I take this one right here into my answer. Are there any questions on this? Alright. I didn't work out the second part of them. Can I see the book? What's your next assignment? Numbers what? 49 through 59. 55, okay? Let's look at that. Is there one in particular you just said, Mr. Cheshire, I need you to work this one? Then in the back of the book, what number was that? 51. Is that the same one, Jessica? Okay, let me do that one. Let me show you why it is what it is. But if you got that different answers, okay, I'm going to show you why. Number 51. It has something to deal with the directions. All right, so let's look at 51. It says find the product of Z1 times Z2. Okay? So we have 51. Let me write this down here. Alright, we want to multiply first. Z1 times Z2. You multiply your R values. Square root of 2 times square root of 2 would be what? 2. 2 times 2 is 4. You're going to add your argument, your angles, your thetas. 5 pi over 3 and 3 pi over 2. What do you get when you do that? What is it? 19 pi over 6. Yep. Plus I sine 19 pi over 6. The reason you see something different in back of the book, and now that I read the directions, I would accept what you have. Sometimes they want it between 0 and 2 pi. Isn't 19 pi over 6 more than 2 pi? Yes. So what they did was they subtracted 2 pi off that, said 19 pi over 6 minus 12 over 2, isn't that 12 over 6, isn't that 2 pi? And they got 7 pi. So they just kept it between 0 and 2 pi, which is the same thing. So I would accept that, okay? TJ, your quiz is on your desk. Yes. Are there any questions on your homework? Okay, let's do the division. Z1 divided by Z2. You would divide these two. So that's square root of 2 over 2 square root of 2. This worked out well because you can do what with the square root of 2's? So you're left with 1/2. Now I'm going to say 5 pi over 3 and 3 pi over 2. I'm going to find a common denominator. 10 pi minus 9 pi is what? Pi over 6. Do y'all see that? Y'all good with that? Plus I sine pi over 6. Is everybody good with that? Are there any questions on your homework? I'm going to come around and look at it and make sure everybody did it, okay? All right, then we're going to continue on. I call somebody's name out. The great was absent. Okay, y'all got your all. You got yours. Oh, don't worry, I got your list of things too. You got yours? Brad, you got yours?
I got the
Keep working on it. On the original problem or that problem? Oh, okay, I got you. Just a second. Good. You got your own. Good. Jordan, absent, Grayson. Good. Got your thing. Daniel. Abby Giles. Conley Brown. Catherine. Okay, thank you. And since you were working on that project too, it's the only time you can bring it in tomorrow for correct. You got it. That's it. Now I will remind you, and you're only going to get half credit, okay? All right. Now, okay, you're talking about the stuff inside. If you're multiplying, like this right here. Does that make sense? All right. So if you so let's talk about this again. If you're multiplying, you multiply the R values and then add the stuff inside. If you're dividing, you divide these two and subtract the thetas. Are we good there? Okay, moving on. Alright, buckle up, buttercups. Here we go. We're going to learn how to find a power of a complex number using de Moivre's theorem. Say de Moivre. Where do y'all think that originated from? What country? France. France. He's a French mathematician. De Moivre's theorem. Do you remember that first semester when we learned how to use Pascal's triangle to expand the binomial like x plus 7 to the 10th? You had to use the triangle and the numbers and expand it out. Well, this is kind of what it is, but with complex numbers, okay? So you're going to expand a complex number using de Moivre's theorem. Okay, so let's look at this. And then this is where we go a little much deeper than pre-EP. Pre-EP didn't have to do any of this. All right. It says, if you have a complex number, if Z is a complex number, and you put it in polar form, so let's say, I'm just saying Z is some kind of complex number with A and B. You got to put it in polar form. Then, whatever the complex number was raised to certain power, you raise the R to the power, and you multiply your thetas by that power. It will make sense. Hold on. Look here. I've worked an example out, so we're going to watch it. Ready? We have some complex number, 1/2 plus 1/2 I raised to the 10th power. That would take a long time to work out to 10th power. Well, here's how you would handle this using de Moivre's theorem. First thing you do is you take this complex number. If you're taking your quiz right now, I just need you to stop, because you will be lost trying to figure this out. I have 1/2 plus 1/2 I to the 10th. So I'm going to expand this. So first thing I do is put it in polar form. In polar form, I need an R and I need a theta. Well, I find my R by finding the modulus. Just like we did last night. The modulus is square root of A squared plus B squared. 1/2 squared plus 1/2 squared gives me 1/4 plus 1/4, which is 2 over 4, which is square root of 2 over 2. Thank you. Square root of 2 over 2. So that goes in front. Now, y divided by x. 1/2 divided by 1/2 gives me 1. It will become from quadrant 1. That's why I have pi over 4 there. Does that make sense? So that's my polar form. So the first thing you'll do is put it in polar form. Now here's where de Moivre's theorem comes into play. It says you're going to take the R value and raise it to whatever powers out here. I raise square root of 2 over 2 to the 10th power. Hey, please take a look at me. To the 10th power. Then you take this power and multiply each of these by. So you're going to raise this to the power and multiply both your thetas by 10. So I come over here. This is what I did. Square root of 2 over 2 to the 10th. This was pi over 4. Pi over 4 times 10 is 10 pi over 4. 10 pi over 4. Is that moon? Earth? Now, square root of 2 to a 10th. Let's talk about that for a minute. If you got square root of 2, how can I rewrite 2? 2 to the 1/2, can I? If I raise that to the 10th, wouldn't that be 10 over 2, which is 5? That's why I have 2 to the 5th right there. You got to be careful on how you simplify it. If you got a square root, rewrite it as a rational exponent. That's why we talked about this. To the 10th would be really 2 to the 5th over 2 to the 10th. Because you got to raise both of them 10. I just reduced this to 5 pi over 2. 5 pi over 2. Now, aren't these like bases? They both have 2's. What's 5 minus 10? Negative 5. So 2 to the negative 5th would be 1 over 2 to the 5th, which is 1 over 32. Do you see how I got that? Okay, do you understand how I got 2 to the 5th right here? Yeah. Okay, so you got 2 to the 5th over 2 to the 10th. Aren't these like bases? You would subtract. That gives you 2 to the negative 5th, doesn't it? How do we get rid of negative exponents? 1 over 2 to the 5th, which is 32. Is everybody good? Okay, so I got that taken part of. Now I got to evaluate this. 2 goes into 5 2 times. I went around the unit circle 1 time. I'm back at the half. So cosine is 0. Cosine sine of 5 pi over 2 is 1. 1 times I is I. So now 0 plus I is I times this is 1 over 32I. That's the answer if you were to multiply all that out. God, it's deep, isn't it? Let's look at number 2. Alright. TJ, no, you can get your notes out and start writing this down, and then you can finish the quiz after I finish these 2 examples. Alright. First thing we need to do is write this in polar form. Okay, so find the modulus. Z equals 2 squared plus 2 square root of 3 squared. Gives me 4 plus 12. Z equals the square root of 16. Z equals 4. Tangent of theta equals b divided by a2 square root of 3 over 2. Theta equals square root of 3. It will come out of quad 1, so your theta is pi over 3. So now I'm going to write that in polar form. 4 cosine of pi over 3 plus I sine pi over 3. So that is my polar form. Take a moment to look at that. Jordan, you got to make a quiz up to sometime today. Alright, do we understand to that point? Now, do you know the cosine of pi over 3? What is that? Oh, wait, hold on. Sorry. Okay. Okay, go back here. What is this right here? 6. You got to raise the r to that power. This is de Moivre's theorem. Raise the r to that power, then multiply each theta by that. So 6 times pi over 3 is 6 pi over 3 plus I sine 6 pi over 3. You should get the same thing on both of these. Now let's clean it up. Take your calculator. 4 to the 6 is what? 4,096. 6 pi divided by 3 would be cosine of 2 pi plus I sine of 2 pi. 4,096. Cosine of 2 pi is 1 plus 1 times 0. So that goes away and you're just left with 4,096 as your answer. So you don't use Pascal's triangle, you use de Moivre's theorem. Right here?
Yes.
Okay, cosine of 2 pi is 1. Sine of 2 pi is 0, so 0 times 1 is 0. So I just say 4,096 times 1. Like that. When you do your paper on your mathematician, somebody can pick de Moivre. Oh, we're doing it. We're doing it, Navy. Yes. Alright, number 3. Yes. Alright. First thing we'll do is find the modulus. Z equals square root of 3 over 2 squared plus negative 1/2 squared. When I square root of 3 over 2, I get 3/4. Because your square root and your square cancels out, leaving that 3, but 2 squared is 4. And when you square this, it's going to be 1/4. Oh, it comes out so pretty. Don't you love it when 3/4 plus 1/4 equals what? 1, and square root of 1 is what? Yep, so my R is going to be 1. Remember, your Z and R is the same. The Z is the modulus, the absolute value, but your R is equal to the absolute value. That's why I put at the end, R equals that, because you want an R value. Does everybody understand that? Okay, now, let's find our tangent. Now, this one's kind of complicated, so I'm going to write tangent theta. I'm going to say negative 1/2, and I write it the horizontal way because I got to see what's going on here. I'm left with negative 1 over square root of 3. By now, you know it's going to be negative square root of 3 over 3. We think, okay, what reference angle gives us a square root of 3 over 3 and the tangent? Is it pi over 3 or pi over 6? And what quadrant do you want that out of? That's going to be quad 4. So that's going to be 11 pi over 6. Alright, so let's write it in polar form. So that'd be 1 cosine 11 pi over 6 plus I sine 11 pi over 6. Do you see why I'm keep stressing? It's very important to study every night to know what you got to do at what situation. Because you have 16 concepts on this test come Friday. And you're not going to come to me and say, Miss Chester, am I doing what it says? I'm not going to tell you. It's an assessment. Okay? So that's why you got to go home and look through and say, okay, if it says this, I know to do this. If it says this, I know to do this. Alright, now, what's my exponent up here? Negative 5. So I'm going to raise my R to negative 5. Multiply my arguments, or my thetas. They're both called arguments. 11 pi times negative 5 is negative 55 over 6. Negative 55 pi plus over 6. Plus I sine negative 55 pi over 6. Now, when you have 1 raised to a negative number, do you really have to worry about that? No. Because that's going to be 1 over 1 to the 5th, isn't it? And what's 1 over 1 to the 5th is equal to? 1. It's not negative 1, because that negative 5 just means you put it in the denominator. Don't change the sign. Does everybody understand that? So it's 1, so that's easy. Now, let's talk about this. Negative 55 pi over 6. How many times 6 go in negative 55? Negative 9 times. How many's left over? 1 6, isn't it? Because 9 times 6 is 54. Alright, so think about this. Negative 9 pi. Where would it be at? Right here. Because we went around it 8 times, and you're back to this negative 9. You got me? I need one more pi over 6. Quad 2 or quad 1? 2. Do you see that? You got to visualize that. Okay, so that's quad 2. So in quad 2, your cosine's what? Negative. So it'd be negative square root of 3 over 2. Your sine will be positive. Okay, then you just distribute. So your answer is negative square root of 3 over 2 plus 1/2 I is your answer. Sometimes you come out to an easy answer like this. Sometimes you're going to have 2 terms. That was the easy part today. The next part we're about to do is a more complicated situation.
Wait, so when it's 1 to the negative 5th, it's not negative 1?
No, because 1 to the 5th, buddy, means you just rewrite it as 1 over 1 to the 5th.
Okay.
Yeah. All right, turn over. Guys, now we're about to find square roots, cube roots, fourth roots of complex numbers. Now, we found roots before, and they've given us complex numbers, haven't we? But we never just set out on an adventure and say, I want to find that square root of that complex number out. Well, today that's our adventure. So learning target 2 is I can find the nth roots of a complex number. I might ask you to find the second root, the cube root, the square root, the fourth root, the fifth root, the sixth root. Now I will give you this formula on the test Friday. That is the formula to doing it right here. That's the only formula you're getting. Is I'm going to put that on the board. All right. We might only get through one example. All right. We want to, and I'm just going to explain it as I go here. In this one right here, I want to find the cube roots of this complex number. Cube roots. Well, the first thing you got to put in polar form. Everything's like, this is not in polar form, is it? So we need to put it in polar form. So let's go do that. So I'm going to find the modulus. We're not in easy pre-cal world anymore, always at. I'm going to square this. 4 squared is 16 times 3 is 48. 48 plus 16 is square root of 64. Yes, comes out to 8.
It won't come out much on the test.
No, not over one of them. There's 32 questions on your test. You can come at 7:40 and start that test. Because you will finish by 9 o'clock. If you do not, you're not going home studying and come back Monday. Whatever you don't finish is marked wrong. Once you start the test, you will finish it by 3 or you will not come back. I'm not going to have that. I'm going to run home and study and come back on Monday. That is not working. So just go on. You need to be at 7:45. At 9, I'm taking up. Now, if you think you can finish it from 8:15 to 9, by all means. Tangent of theta equals 4 divided by 4 square root of 3. Gives me 1 over square root of 3, which I know it comes out to be square root of 3. Now, I look back here. That's going to be in quad 1. What pi over what family gives me this? Well, pi over 6. It comes in quad 1, so that's going to be pi over 6. So I'm going to write that as 8 cosine pi over 6 plus I sine pi over 6. So that should be easy. That's just like what we've been doing, putting in polar form. Now let me explain to you this formula right here. Like I said, I can't memorize this, so I'm going to give this to you. Alright, what this formula is saying, guys, is you're going to raise r to whatever root you're trying to... How can I write the cube roots as an exponent? 1 over what? 3. So you raise that to the root, 1 over 3, because you're dealing with cube. Does that make sense? You remember that 2k pi comes back in, or 2n pi, whatever you want. 2k pi comes back in, and you're going to divide it by the root that you were going after, 3. Like here, I want to divide that by 3. So let's set that up. So, I'm going to write 8 to the 1/3 cosine pi over 6 plus 2k pi over 3 plus I sine pi over 6 plus 2k pi over 3. And the way I got the 3 is depends on the root. If they had said 4th root, I would put a 4 right here. I would put 1 over 4, 4, 4. If I said 5, that'd be 1/5, 5, 5. Alright, what's the cube root of 8? 2. We're going to there's 3 roots. So guess what I'm going to plug in for k? 0, 1, and would they give me 3 values? If I said 5, I would plug in 0, 1, 2, 3, 4, wouldn't I? So for 3, I'm going to plug in 0 for k, get an answer. Plug 1 in, get an answer. Plug 2 in, get an answer. You got to work this 3 times. So here we go. Plug 0 in for k. What's pi over 6 plus, well, that goes away for 0, don't it? So what's pi over 6 divided by 3? Would that affect the numerator or denominator? So that gives you cosine of pi over 18 plus I sine pi over 18. You said, Mr. Chester, whatever you get over here, you get over here. Yes, you only got to work it one time. So that's one answer. Now I'm going to plug 1 in. 2 times 1 is 2. That gives me 2 pi plus pi over 6. 2 pi plus pi over 6 will give me 13 pi over 6, wouldn't it? If you put it in the calculator. You have 13 pi over 6 divided by 3. Will that 3 affect the numerator or denominator? When you flip 3, wouldn't it be times it by 1/3? So it's going to affect the denominator, wouldn't it? If you can't see that, you need to put that in the calculator. So what would that be? 13 pi over what? 18. That doesn't go over 2 pi, does it? So we're good. Next one. If you've not seen how I'm doing this, I'm going to plug 2 in. 2 times 2 is 4. Watch how I do this. So I got 4 plus. Okay, I said that. Change that to a fraction. Then I'm going to divide by what? 3. Do you see I got 25 over 18? That will be my next value. And those are your 3 answers. Those are the cube roots of that complex number. So if you have to use your calculator to plug that in and do it, then do that. But if I was to take the cube root of that, those are my 3 answers for that root. What now? Yeah, no, sometimes you're going to get fractions. This is an easy one.
But they all stay the same.
Yes. All right, we're going to finish. Do you think you're ready for that test tomorrow?
No.
So we can push it Friday. So you need to study next 2 days. Okay, we're going to do some more of these tomorrow. But your homework assignment is page 610, 30 to 38 even, 65 to 67 all, and I gave you 2 to practice on this. We got 2 more examples. Oh, look at this one tomorrow. How many roots we got to find? 6. We got to plug in 0 to 5. Why don't you do this, guys? Don't do 77 and 79. Try to do number 2 on here and do the other 2. Like do 30 to 38 even, 65 to 67 all, and try number 2, okay? Does everybody understand? The one on the test, I think, is cube roots. I don't think you do a 6 root. Keep working it out right to that. Plugging in 0 for K, and then working out your tag. Plug in, get that. Plug 2 in, I get that. Yeah, and I plug in. If I have 4 roots, I plug in 0 to 6. Y'all have a great day. Let's go on our journey.
Wait for me, I want to come see.
Hold up, I got. Yes. Okay. Go ask your teacher. Or no, do you want to just come and run back 4 feet and finish it up?
Not really. I'd rather just read it from the past.
Okay.
I'm going to say mine will through.
Yes. Come back. Yes, I got to take Zach right now. You finished? What do you get?
I'm in this class in the I'm coming back. Because I don't know what I'm going to do.
You can't.
Come back. Oh, but just today? Oh, what?
Sequences. And geometry. Pascal's triangle. It's something. I mean,
Oh, y'all were just on those guys?
well, y'all just
We've done that. We're doing something else with it. We're doing like complex calculus.
pass. Not pass. Yeah. Where'd you get that?
My first year.
You don't want to pop.
We had
Can I keep it?
You should have
like pictures for golf or whatever, so we missed.
Oh, yeah.
Is that one of those?
You took his stress ball? Bro, he's gonna come looking for you.
And it says, make sure you get your tree.
back to IT.
Why?
Someone walking in the hallway.
Why is he taking this?
Because I just put it wrong with it.
I don't know exactly what's going on. Look, I know he's gonna ask for it, but I just don't know. He calls it into 10.
She really didn't call me. She said I should.
So she didn't tell you that we had it.
Yeah.
Because you're overreacting.
Wait, what? You said.
Yeah.
You're overreacting.
And I was like, whatever.
Wait, who called who? What?
Nothing. I talked to you.
Because you know, if he hears you say that, when he walks back up there, he's gonna start playing. Get your crap. Play out before this test. I didn't do that. I got most of it.
Happy Pi Day 2K18.
Is it 3.14?
Yes, and my video, I hope no one said ugly word while I was gone. My video's still recording.